The alarm panel screamed at the exact moment the main engine failed and the rudder stuck hard over to port, catching the current on our quarter and twisting the bow straight toward the massive steel gates of the lock. And I watched the distance to impact drop from 3 cables to 2, while the ship drifted helplessly sideways with 5,000 tons of momentum pushing us forward. We were fully loaded with grain. The ship was heavy and sluggish. The river current was pushing directly on our stern, amplifying the swing. The pilot looked at the RPM gauge, which was falling rapidly to 0, and then checked the rudder angle indicator. It was dead frozen at 10 degrees port. The sudden silence of the main engine stopping was heavier than the noise of the alarms. We were drifting into the approach wall, but the angle was wrong. If we hit the wall at this angle, we would crush the hull plates at the shoulder. If we missed the wall, we would smash directly into the lock gates ahead. There was no time to call the engine room to ask what happened. The captain grabbed the phone, but we all knew the engineers were already scrambling below. We were transiting the St. Lawrence Seaway downbound toward Montreal. It was late afternoon with clear visibility and light wind. The vessel was a standard handy-sized bulker. We had been making about 6 knots to maintain steerage in the current. In that narrow channel, you need water flowing over the rudder to steer effectively. When the screw stopped turning, the rudder became almost useless. The bank effect, the pressure of water between the hull and the channel bottom, started to interact with the hull immediately. The stern sucked in toward the bank, pushing the bow out toward the center, but the stuck rudder kept us turning. We were losing the center of the channel. The lockmaster radioed us, asking if we were having trouble. The pilot picked up the VHF handset. Lost engine, lost steering, keep the gates closed. Before I tell you what happened next, please consider subscribing. It helps this channel reach more sailors. The bridge team fell into a practiced routine, even though the situation was critical. The third officer went to the telegraph and pumped it to stop, and then full astern, hoping to trigger a restart logic in the engine control room. But nothing happened. The tachometer stayed at 0. The ship was still moving at 5 knots over the ground. That is too fast for the bow thruster to be effective. The thruster works best when the vessel is stopped or moving very slowly. At 5 knots, the water flow washes out the thrust. We tried it anyway. The captain turned the thruster dial to full starboard to push the bow away from the wall. It made a loud hydraulic whine, but the bow kept swinging to port. We were drifting diagonally now. The distance to the concrete tie-up wall was less than 1 cable. The pilot turned to the captain. "We need to slow her down. Anchors?" The captain hesitated for a fraction of a second. Dropping an anchor at 5 knots with a fully loaded ship is dangerous. The brake linings can burn out, the chain can part, or the flukes can catch the bottom and rip the windlass motor right off the deck. But we had no choice. The concrete wall was coming fast. The captain picked up the UHF radio to the forecastle. "Chief officer, stand by both anchors. Prepare to let go." The chief officer replied instantly. "Standing by. Both anchors ready." On the CCTV screen, we could see the deck crew running to the brake handles. They knew something was wrong by the extreme angle of the ship relative to the channel. The ship was now sliding sideways, blocking the entire approach. The stern was getting dangerously close to the rocky bank on the starboard side, while the bow aimed for the port side wall. It was a classic sheer, uncontrolled turning in a confined waterway. "Let go port anchor, 1 shackle in the water," the captain ordered. He wanted to drag it, not dig it in. If it dug in hard at this speed, the chain would snap like thread. We needed drag resistance. The chief officer opened the brake. We saw the rust and dust fly on the monitor as the chain ran out. "Port anchor is away," the radio crackled. The ship shuddered as the anchor touched the riverbed. The chain pulled tight, then jumped violently. The brake smoked visibly on the camera. The chief officer was tightening the brake band to create friction, trying to slow the ship without breaking the gear. But the momentum of the loaded vessel was too great. The ship didn't slow down enough. The bow swung slightly, but we were still closing on the wall. The current was relentless. It kept pushing the stern, trying to spin us around 180 degrees in a channel that was barely wide enough for the ship's beam. "Engine room, what is the status?" The captain yelled into the phone. The chief engineer's voice was calm but urgent. "Air pressure low, 1 compressor running. Give us 30 seconds. 30 seconds is a long time when you are moving at 5 knots toward a solid object. In 30 seconds, we would travel another 75 meters. We didn't have 75 meters of clearance left. The pilot looked at the tie-up wall. "She's not checking. We need the starboard anchor. Dredge both." The captain nodded. "Let go starboard anchor. Short stay." 2 anchors dragging might generate enough resistance to stop the slide. The starboard chain roared out. Now we had 2 heavy weights dragging on the bottom, kicking up mud. The vibration traveled up through the hull to the bridge. You could feel the steel grinding on the rock and mud below. The speed over ground log dropped, 4.8 knots, 4.5 knots. It was slowing, but not fast enough. The angle was the problem. The bow was now pointing almost directly at the concrete fenders of the lock entrance. If we hit the corner of the wall, it would punch a hole in the collision bulkhead. "Rudder is responding," the helmsman suddenly said. The emergency steering pump had finally built enough pressure. "Hard to starboard," Burstad, the pilot ordered Ryan. "Get the stern away from the bank." The helmsman spun the wheel. We waited. Without the propeller wash, the rudder is just a metal plate. It has very little effect. The ship groaned. The anchors were dragging, holding the bow back, but the stern kept swinging. We were turning broadside to the lock. The alarm bells were still ringing, but nobody heard them anymore. All eyes were on the concrete wall filling the window. The gap was closing. 10 meters, 5 meters. The deck crew on the bow started running back toward the accommodation. They knew the crash was coming. The collision happened in slow motion. The port bow shoulder made contact with the wooden fendering on the approach wall. It wasn't a sharp crash. It was a deep, grinding shudder that vibrated through the deck plates and rattled the coffee cups on the bridge console. We watched the fender piles compress and then shatter under the weight of the hull. Splinters of heavy timber flew into the water. The friction of the steel against the wall acted like a third brake, finally checking our forward momentum. The hull groaned loudly as the plates flexed, but the ship stopped sliding forward. We were dead in the water regarding headway, but the situation was not stable. The bow was pinned against the wall by the current, but the stern was still free and swinging out into the channel. The current in the St. Lawrence is powerful. With the bow stuck on the wall and the anchors holding the front end, the river current caught the stern section like a sail. The ship began to pivot. The stern swung out toward the center of the channel. If we swung 90 degrees, we would block the entire Seaway. Worse, the stern could swing all the way around and smash the propeller and rudder into the opposite rocky bank. We were effectively pinned by the bow, rotating out of control. The anchors were leading straight down now, skipping on the bottom as the bow ground against the fenders. The pilot watched the rate of turn indicator. It was increasing. 10 degrees per minute, 15 degrees per minute. "Engine room, we need power now," the captain said into the phone. He didn't shout. Shouting doesn't make the air compressors work faster. "Ready for start. Air pressure is marginal, but we can try," the chief engineer replied. "Transfer control to bridge immediately," the captain ordered. He slammed the telegraph handle to stop to reset the system, then looked at the pilot. The stern was now 30 degrees off the wall. We were taking up half the river. The pilot nodded. "Hard starboard. Give her a kick. Dead slow ahead." The captain moved the telegraph to dead slow ahead. We all stared at the tachometer. This was the critical moment. The main engine starts with compressed air. If the pressure is too low because of the blackout, the engine turns over a few times and dies. If it dies now, we have no more air for a second attempt. The stern would continue to swing until we hit the rocks on the other side. The needle on the RPM gauge flickered. The engine rumbled deep in the hull. It caught. The shaft began to turn. 10 RPM, 15 RPM. "She's firing," the third officer said. "Give me half a head," the pilot said. "We need wash over the rudder to check this swing." It was a risky move. We were pinned against the wall at the bow. Applying half a head meant driving the ship forward against the friction of the wall and the drag of 2 anchors. If the anchors held too tight, we might drive over the chains and damage the hull plating. If the wall friction was too high, we might strip the steel plating right off the bow, but we had to stop the stern from swinging. The captain pushed the lever to half a head. The vibration increased. The propeller churned the water at the stern, sending a wash of turbulent water over the rudder, which was hard over to starboard. The physics of the maneuver is simple. The propeller drives water against the angled rudder, creating a side force that pushes the stern back toward the wall. We watched the rate of turn indicator. It hovered at 15 degrees per minute to starboard, swinging out. It didn't stop. The current was fighting the engine. Not enough, the pilot said. Full ahead, just for 10 seconds. Full ahead, the captain repeated. He pushed the lever all the way up. The engine roared. The ship surged. The bow ground violently against the concrete wall, screeching as metal scraped stone. The anchors hammered on the hawse pipes. The tension on the chains was immense. We were dragging 2 heavy anchors and scraping a wall while pushing full power. The whole ship shook like it was coming apart. Rate of turn is dropping, the helmsman called out. 10 degrees, 5 degrees. The stern started to move back toward the wall. The prop wash was finally winning against the current. Stop engine, the pilot ordered immediately. We didn't want to gain forward speed and rip the anchors off the windlass. The captain pulled the lever back. The engine fell silent again. The momentum of the swing carried the stern in. It drifted closer to the wall. The danger wasn't over. As the stern came in, it was moving fast. If the stern slammed into the wall, we could damage the propeller or the steering gear we had just regained. Hard to port, the pilot ordered. Hey, check the swing. The helmsman spun the wheel. We needed to use the remaining momentum to cushion the landing. The rudder moved, but without the engine turning, it was sluggish. The stern closed the distance, 20 meters, 10 meters. Dead slow ahead, the pilot said, just a touch. The captain gave a short burst of power. The rudder bit the water. The stern slowed its inward swing. It drifted gently alongside the fender line. Stop, engine. The ship settled against the wall. We were parallel. The bow was resting against the broken fenders. The stern was 5 meters off. The ship was stopped. The anchors were leading aft, tight as piano wires. Hold her here, the pilot said. Do not let that stern move out again. The phone rang. It was the chief engineer. We have full electrical power restored. 1 generator is online and stable. 2nd generator synchronizing now. Steering pumps are both running. The captain exhaled a long, slow breath. Understood, Chief. Keep the engine on standby. We are alongside the approach wall. We weren't safe yet. We were parked in a precarious position. The port anchor chain was leading aft, likely wrapped around the bow or running under the keel. The starboard anchor was crossed over the port chain. We had destroyed a section of the lock authority's wall. We had to figure out if the hull was breached, but the ship was stationary. We weren't drifting. We weren't sinking. Get the chief officer on the radio, the captain said to the 3rd officer. Tell him to check the hull plating in the collision zone, sound the forepeak tank, and tell him to be careful. That anchor chain is under extreme tension. I looked out the wing window. Down on the foredeck, the crew was stepping cautiously around the windlasses. The brake bands were smoking slightly. The paint on the ship's side was stripped to bare metal where we had ground against the wall. But the channel was clear. We hadn't blocked the Seaway. The lockmaster came over the VHF. His voice was shaky. Captain, what is your status? Do you require tug assistance? The captain picked up the handset. We are alongside the wall. Power is restored. We are checking for damage. Stand by. He put the radio down and looked at the chart table. His hands were steady, but his face was pale. The silence on the bridge returned, but this time it was a controlled silence. The panic was gone. Now it was just work. We had to untangle the anchors, assess the damage, and explain to the authorities why we had just smashed their dock. That was close, the pilot muttered, making a note in his logbook. Too close. The immediate crisis of the drift was over. Now we had to deal with the mess we had made. The ship was safe, but the paperwork was just beginning. The immediate silence on the bridge was replaced by the static of radios and the ringing of the engine room telephone. We were secure alongside the wall, but the vessel was in a compromised state. The first priority was confirming watertight integrity. If the collision had cracked the hull plating below the waterline, we would be taking on water in the forepeak tank. The chief officer was already down on the foredeck with the carpenter, dropping a sounding tape into the sounding pipes. Bridge, foredeck, the radio crackled. Sounding forepeak tank. Tank is dry, no water ingress, but I can see external damage to the shell plating above the waterline. Frames 150 to 160 are indented. The steel is dished in about 10 centimeters. The captain acknowledged the report. Understood. Check the bow thruster room, check the paint locker. I need to know if we have any internal structural failure. While the deck crew inspected the steel, the pilot was talking to the Seaway traffic control. The lock was officially closed. No other ships could transit until we moved. The authorities were sending an inspector down to the wall to check the damage we had caused to their fenders. We couldn't leave until they cleared us. But before we could even think about moving into the lock, we had to recover the anchors. This was a complex seamanship problem. We had dropped the port anchor while moving, then the starboard. The ship had spun and drifted. The chains were likely crossed, or worse, the port chain was leading under the hull. If we just started heaving on the windlass, we could drag the chain across the underwater hull paint or damage the bilge keel. Chief Officer, prepare to recover starboard anchor first, the captain ordered. It was the last one down. It should be on top. The windlass hydraulic motor started to whine. The chain came up slowly. It was covered in Gray River mud. The deck crew used high-pressure fire hoses to blast the mud off the links as they came through the hawse pipe. You have to clean the chain, otherwise the mud dries like concrete in the chain locker and rots the steel. The chain was leading aft, tight against the ship's side. Chain is tight. Leading aft, 6 o'clock, the chief officer reported. Dead slow ahead, the pilot ordered. We needed to move the ship forward gently to take the tension off the chain so the windlass could lift it. The ship crept forward along the wall. The tension eased. The chain hung vertical. Anchor is away, the bow reported. The starboard anchor broke the surface. It was fouled with a thick steel cable from the bottom of the river, likely old logging debris or a discarded tow wire, but it was clear of the other chain. We were lucky. The crew cleared the debris with a crowbar and housed the anchor. Now for the port anchor. This was the one that had taken the most strain. The chain was leading under the bow, across the stem. It was tight. The chief officer tried to heave, but the windlass relief valve lifted immediately. The hydraulic pressure maxed out, but the chain didn't move. The anchor was dug in deep, or it was caught on a rock ledge. We need to break it out, the pilot said. She's dug in hard. We had to maneuver the ship to pull the anchor free. The captain ordered the rudder hard to port and the engine to slow ahead. The idea was to swing the bow slightly away from the wall to change the angle of the pull. The ship moved. The chain rattled in the hawse pipe. Heave away, the captain ordered. The windlass groaned again. Slowly, link by link, the chain came in. The strain was audible, a deep popping sound as the links adjusted on the Gypsy. Then a sudden shudder went through the deck. The anchor had broken free from the bottom. Anchor is away, coming up, the chief officer said. When the port anchor broke the surface, the flukes were shiny metal. The paint had been sandblasted off by the riverbed. One of the flukes was slightly bent, evidence of the extreme force when it hooked the bottom at 5 knots. But it was functional. We housed it and secured the break. The Seaway inspector arrived on the jetty 20 minutes later. He walked along the wall, taking photos of the smashed wooden fenders and the scrape marks on our hull. He came on board to speak with the captain. It was a calm, bureaucratic discussion. We had to sign a letter of undertaking, guaranteeing that our insurance would pay for the wall repairs. He checked our steering gear logs and the engine printout. Since the power was restored and tested and the hull was watertight, he gave us permission to proceed. Engine is ready. Steering is tested. Anchors are secured, the captain said to the pilot. Let's get out of here. We cast off the mooring lines. The pilot called for dead slow ahead. The ship moved sluggishly. We entered the lock chamber at a crawl. Usually you enter a lock at 2 or 3 knots. We did it at 1 knot. The crew on the bow was silent, watching the concrete wall slide past with only inches of clearance. The trust in the machinery was gone. Every time the engine vibration changed pitch, heads snapped up to look at the RPM gauge, but the plant held. We tied up inside the lock. The gates closed behind us and the water level began to lower. We were through the bottleneck. The rest of the transit to Montreal was tense. The captain stayed on the bridge the entire time, sleeping in the pilot chair. The chief engineer stayed in the control room watching the generator parameters like a hawk. We didn't have another incident, but the atmosphere on board had changed. We had come within meters of a major disaster. We docked in Montreal the next morning. The company sent a superintendent and a technical team to investigate the blackout. A team of divers went down to inspect the underwater hull. The report came back a few hours later. The damage was mostly cosmetic, scraped paint and minor indentations on the bow plates. We didn't need dry docking. We could continue cargo operations. The cause of the blackout was found 2 days later. It wasn't a major component. It wasn't the main engine or the generators themselves. It was a faulty vibration sensor on the fuel rack of the #1 generator. The sensor had failed, sending a false high vibration signal to the safety system. The system did exactly what it was designed to do. It shut down the generator to prevent damage. The second generator tried to take the load, but the sudden spike was too fast and the breaker tripped, causing a cascade failure. A sensor worth $50 had failed. Because of that small plastic part, a $20 million ship carrying $5 million of grain nearly blocked one of the most important waterways in North America. The repair took 10 minutes. The crew replaced the sensor and tested the system. It worked perfectly. That is the reality of modern shipping. You can have the best seamanship, the most experienced pilot, and a well-maintained vessel, but you are always reliant on the smallest link in the chain. The incident goes into the file as a near miss. The company sends a fleet circular warning about checking sensors. The insurance pays for the wooden fenders on the lock wall. I retired a few years after that. I still think about that afternoon in the Seaway. I think about how quiet the bridge was when the engine died and how loud the anchor chain sounded when it ran out. It reminds you that the margin between a routine voyage and a shipwreck is often just a matter of seconds and luck. We had good luck that day. The fenders held, the anchors held, the wall held. If you have ever had to drop anchors at full speed, let me know in the comments.